Okay, in this example we have two metal spheres that are 1 kilogram each, and we have a force between them that we measure. We want to know the distance between the spheres. So this is just a variation of the Cavendish experiment where we're actually trying to solve for distance instead of actually having distance already. So let's look at this and we say, okay, we are trying to solve for the distance, or the d. We know that we are going to use Newton's law of universal gravitation. And we can go ahead and draw it out. You have a 1 kilogram object. You have another 1 kilogram object. You know the attractive force. And you want to figure out what the distance is between them. So let's look and see if we can figure this out. So our given information, you know that mass 1 is 1 kilogram. You know that mass 2 is 1 kilogram. You know that the force between them is 1 times 10 to the minus fifth. And then you always know that g is a constant. So when we look at this, we can say Fg is equal to capital G m1 m2 over d squared. Remember, this g is just defining this as the gravitational force. It's not 9.8 there. Remember, it's a little subscript. It should be maybe a little smaller like that, Fg. So I'm going to rearrange and I'm going to solve for d. How I'm going to do that is I'm going to basically switch this term and this term, multiply both sides by d squared, divide both sides by f, and when you do that you get d squared equals g m1 m2 over f little g. So now, in order to figure out what this is, I would take the square root of both sides, and that would give me my d value. So now, the square root of 6.67 times 10 to the minus 11th times 1 divided by 1 times 10 to the minus 5th, and that would allow me to figure out my distance. So I'd say 6.67 e minus 11 times 1 divided by 1 e negative 5. Now this is the value that's all of these numbers right here. So at this point, what I need to do is I need to take the square root of it. So I take the square root at the end. And when I do that, I get a value of 0.0026 meters, which is about 2.6 millimeters as far as the distance between them, which is not entirely possible because this is actually the center to center distance, and assuming that the spheres have any sort of shape at all, it's going to be almost impossible for that to occur. So you're looking at very, very, very small forces for gravity for everyday objects. The only time you get large values is when you talk about things that are like planets and stars and so forth.